Olá, espaçonauta! Isso aí, galera, né? Estamos de volta aí com os vídeos, né? E sabe quem voltou também? É o Alfredo Lopes Morais, nosso colaborador lá de Portugal. O Alfredo tinha mandado um vídeo incrível nessa fase que eu estava aí sem voz, que eu não consegui nem postar para vocês, porque não tinha como fazer a abertura, né? Então, ele reenviou para mim aqui um vídeo fantástico sobre a Voyager 1. Aliás, Alfredo é show de bola, né? Porque o nível de produção, né? O tanto que o Alfredo produz, acho que ele produz até mais do que eu. Ele pega os vídeos, galera. O Alfredo é apaixonado pelo espaço também, igual a gente mesmo. E ele pega esses vídeos aí em inglês, traduz, faz as legendas, faz todo esse trabalho e envia pra gente divulgar aqui e compartilhar com vocês. Então, merece aí o nosso salve, não é? Manda um salve aí e um agradecimento para o Alfredo, que colabora muito com a informação e com o nosso canal aqui. Aliás, muita gente fica falando assim, gente, mas tá o Alfredo, fala, mas quem é o Alfredo? Tá o Alfredo, galera, ele é artista plástico. E eu vou apresentar para quem ainda não conheceu o Alfredo aí, é esse senhor que tá aqui, ó. Meu amigo Alfredo tá aí, ó, no ateliê dele, show de bola, né? Grande abraço, Alfredo, muito obrigado por tudo aí. Bom, gente, é o seguinte, agora que vocês já viram o Alfredo, já conhecem ele, né? Já ficou mais próximo aí, porque já conhecem pessoalmente. O vídeo que a gente traz para vocês hoje aqui, com legenda, tradução e legendas aí do Alfredo, é um vídeo sobre a Voyager 1, sobre o despertar da Voyager 1, 40 anos depois, rumo ao espaço profundo, né? No caminho de sair do sistema solar. Por que isso é incrível? Porque a Voyager 1, que foi lançada há mais de 40 anos, fez para que vocês tenham ideia, eu era adolescente na época e foi uma das coisas que me despertou para a ciência. Na verdade, eu era criança, aliás, e me despertou para a ciência foi justamente acompanhar nos jornais fotos e imagens que chegavam da Voyager 1, incrível. Então a Voyager 1 desbravou para a gente aí os planetas gigantes aí do Sistema Solar, né? Júpiter, Saturno, foram as melhores imagens que a gente viu até então, feitas por essa sonda, né? Pelas Voyager, né? A 1 e a 2. E eu tenho muito carinho e por isso veio muito a calhar o Alfredo ter mandado esse vídeo aqui, que conta exatamente a saga de quando, um pouco da saga da Voyager 1 e quando eles captaram o sinal dela a já milhões e milhões de quilômetros da Terra aí. Lembrando para vocês que a Voyager 1 é o objeto mais distante da Terra já construído por mãos humanas. É incrível. O vídeo é bacana, viu? Vale a pena, vocês vão curtir demais. Vamos lá?
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
NASA engineers have re-established communication with the Voyager 1 spacecraft, Earth's most distant emissary, after months of troubleshooting a glitch that had rendered the probe's transmissions unreadable.
What shocking discovery has NASA's Voyager probes made after 45 years in orbit? Despite having little memory and sluggish data rates, these 1977 launched spacecraft have been at the vanguard of interstellar research for a considerable amount of time. But Voyager 1 has recently returned data that has scientists puzzled and worried. Information about the control system is inconsistent with how it is now operating, suggesting an impossibility. Come along with us as we explore the universe to solve this riddle. On September 5th, 1977, Voyager 1 was launched into orbit from Cape Canaveral, Florida, using a Titan IIIe Centaur rocket. An incredible trip had begun with this. On August 20th, 1977, 13 days prior, Voyager 2 began a corresponding space mission, starting a parallel trip. Their primary objective at first was to investigate the moons of the gas giants Jupiter and Saturn in our solar system. These brave adventurers far exceeded their original objectives by embarking on a trip that would lead them to the furthest reaches of our cosmic neighborhood. Voyagers 1 and 2 have broken many records during their historic mission, having outlasted every previous spacecraft in history. They have flown farther from Earth than any other human-made object. In interstellar space, these are the first objects created by humans. first spacecraft to sail past Uranus. It made history in 1986. That was the sole spacecraft to fly past Neptune, having done so 3 years later. From Neptune's ferocious winds and icy volcanoes on Triton to the hitherto undiscovered moons of Uranus, this amazing voyage provided a plethora of knowledge about these far-off ice giants. NASA has implemented multiple procedures aimed at extending the spacecraft's operating lifespan while it continues its amazing voyage. By turning off heaters and non-essential parts to save energy, the spaceship will continue to operate far beyond the next 10 years. Since the Voyager's mission is planned to conclude in 2030, this meticulous management guarantees that they will be able to continue returning data as long as possible. For the scientists and engineers who have been involved in this amazing journey from the beginning, the Voyager mission's end is a moment of mixed emotions. A mission far more successful than anyone could have imagined has resulted from their commitment and tenacity. Many scientific advances and significant new understandings of our solar system and beyond have resulted from the data that the Voyagers brought back. Future generations of scientists and space enthusiasts have also been inspired by them. Beyond our wildest expectations before their launch, the Voyagers have experienced and captured the wonders of our solar system. These missions have revolutionized our knowledge of these celestial worlds, revealing secrets like the frozen shell of Europa, the towering volcanic plumes on Io, one of Jupiter's moons, and the amazing discovery of Jupiter's thin rings. Previously believed to be lifeless and desolate, the amazing pictures and data they returned showed lively and active worlds. New questions emerged as Voyager 2 traveled farther and encountered Neptune and Uranus. Highlighting the richness and complexity of our solar system's outer planets, information gathered by the Voyagers on magnetic fields, plasma waves, and cosmic rays is still very helpful in understanding the composition of interstellar space and the mechanisms forming our galaxy. The longevity and success of the Voyager missions are witness to the creativity and dedication of the scientists, engineers, and technicians who designed, built, and operated the spacecraft. The Voyagers have persevered in operating despite the extreme conditions and great distances they have traveled, returning data that has revolutionized our knowledge of the solar system and beyond. The missions have also brought attention to how critical robotic exploration is to advancing our understanding of the cosmos. NASA has put policies in place to preserve the Voyagers' remaining energy and prolong their missions as long as feasible as they get closer to the conclusion of their operational lives. The spacecraft are anticipated to survive until at least 2030 if they carefully manage their energy supplies and shut off non-essential systems. Our knowledge of the interstellar medium and the outermost regions of the solar system will be considerably enhanced by the data they return during this period. Beyond their contributions to science, the Voyager missions leave behind a lasting legacy. Each spaceship is equipped with the recognizable golden records, which are audio and visual records that showcase the variety of life and civilization on Earth. These documents are a message to any future extraterrestrial civilizations that could come across the spacecraft. The golden records' presence reflects humanity's interest in and desire to establish connections with the larger cosmos. The Voyager spacecraft's breathtaking images confirm the odd signals picked up from Io. These photos show a dynamic terrain characterized by towering volcanic plumes and the discharge of volcanic debris. Pele, a well-known volcano on Io, is one of its most spectacular characteristics. Its eruptions have reached heights 30 times higher than those of Mount Everest, erupting across an area about the size of France. More than 33,000 images of Jupiter and its moons were taken by the Voyager spacecraft, demonstrating the grandeur of the planet and the remarkable diversity of moonscapes in the Jovian system. The twin Voyagers have continued to make groundbreaking discoveries ever since they were launched. The discovery that Jupiter had rings was among the most unexpected. These rings, however faint, increase the mystery surrounding the gas giant. In addition, earlier theories concerning these far-off celestial entities were called into question when Voyager 2 discovered that Europa, one of Jupiter's 53 named moons, had an icy crust more than 60 miles. This discovery opened up new directions for planetary science research by enticing scientists to look at the possibility of ice moons being habitable. The Voyagers got a vital gravity boost following their mission at Jupiter, which gave them one last push toward Saturn. They would never have been able to break free from the gravitational pull of the sun and travel farther into space without this essential push. Voyagers 1 and 2 split up soon after, each traveling to uncharted territory. Voyager 1's trajectory brought it very near Titan, the moon of Saturn, which is enveloped in a thick orange atmosphere. Scientists' curiosity over Titan's mysteries led to more research into its intricate composition. After that, Voyager 1 moved north, leaving the planet system and starting its ascent outside of our solar system. On the other side, Voyager 2 set off on an extraordinary journey that brought it to the solar system's outermost planets. It made a landmark flyby of Uranus in 1986, finding 10 moons that were previously undiscovered, and thus expanding the number of known satellites on the planet. Voyager 2 arrived at Neptune 3 years later, exposing the amazing features of this far-off ice giant. Voyager 2 reported wind speeds of up to 1,000 miles per hour during its approach with Neptune, the fastest wind yet measured on a solar system planet. Upon approaching Neptune's methane-laden azure atmosphere at a distance of 2,980 miles, the spacecraft offered unparalleled perspectives into this distant planet. It was discovered that Triton, the biggest moon of Neptune, is among the solar system's coldest locations, with surface temperatures falling as low as -381 degrees Fahrenheit. Triton also displayed unusual geological features, such as ice volcanoes that erupted up to 5 kilometers into its thin atmosphere, spitting frozen particles and nitrogen gas. Our knowledge of the variety and complexity of celestial bodies in our solar system, even in its furthest reaches, has increased as a result of these findings. In addition to expanding our understanding of the outer planets and their moons, Voyager 1 and its thin atmosphere. Our knowledge of the variety and complexity of celestial bodies in our solar system, even in its most distant areas, has increased as a result of these findings. Astronomer Carl Sagan was one person who was instrumental in the missions going above and beyond their original objectives. As an imaging team member of the Voyager mission, he strongly supported taking one more round of pictures before the cameras on board both spacecraft were shut down. A farewell gift to humanity, these pictures would provide a last look at Earth from the far reaches of space. Sagan's perseverance was rewarded. Voyager 1 aimed its camera back toward the inner solar system on Valentine's Day, 1990, and took a set of 60 pictures. The most well-known of them, dubbed the Pale Blue Dot, is nonetheless an enduring representation of our position in the universe. Captured at a staggering 3.8 billion miles away, this is the farthest photograph of Earth yet documented. In the expanse of space, Earth appears as a small, pale blue speck that is hardly noticeable. A story of incredible sturdiness and longevity, the Voyager mission reads like a comedy of space-age superheroes. They've been sending us useful data from the farthest regions of our cosmic neighborhood for 40 years now. Let's now discuss their antiquated 8-track cassette technology. Yes, you read correctly. The Voyager probes still utilize the 8-track records that were so popular in the 1970s. The fact that these reliable cassettes have endured over time is evidence of the mission's creators' brilliance. You might question, but why 8-track tapes? The concept of digital storage as we know it now was very new during those early space exploration days. They therefore required a dependable and long-lasting data storage solution, and the 8-track tapes worked well for it. They resemble the cosmic age's unbreakable workhorses. Even more astounding is the fact that the information on these cassettes contains priceless scientific data about the outer planets, moons, and interstellar space, rather than simply ordinary music. These cassettes are the key to unlocking some of the universe's greatest mysteries. When considering durability, keep in mind that the Voyager spacecraft are subjected to high temperatures, space vacuum, and cosmic radiation. Still, these elderly adventurers continue to go. It's similar to sending grandparents on an Arctic hike where they not only make it through, but flourish. The experiences that Voyager 2 had with Neptune and Uranus were equally revolutionary. During the probe's approach to Uranus, it was discovered that the featureless blue-green planet had many moons, including the fascinatingly active Miranda and a complicated magnetic field. Humanity received its first detailed photographs of Neptune in 1989, when Voyager 2 passed close to the planet, revealing its vibrant atmosphere, deep blue color, and great dark spot. In addition, the spacecraft confirmed that there are weak rings surrounding the planet and found 6 additional moons. The Voyager's equipment continued to send back important scientific data as they traveled farther into space. Crucial data regarding the heliosphere, the bubble-shaped area of space dominated by the sun's magnetic field and solar wind, was supplied by the probe. The Voyagers were able to investigate the interstellar medium, the sparse environment between the stars, after passing through the heliopause, which marks the edge of the heliosphere. The unexpected rise in cosmic rays found in interstellar space is one of the most astonishing recent findings from the Voyager probes. This discovery has caused scientists to reconsider their theories about the interstellar medium and the environment beyond our solar system. The information gathered by the Voyagers on magnetic fields, plasma waves, and cosmic rays is still very helpful in understanding the composition of interstellar space and the mechanisms forming our galaxy. NASA has put policies in place to preserve the Voyagers' remaining energy and prolong their missions as long as feasible as they get closer to the conclusion of their operational lives. The spacecraft are anticipated to survive until at least 2030 if they carefully manage their energy supplies and shut off non-essential systems. Our knowledge of the interstellar medium and the outermost regions of the solar system will be considerably enhanced by the data they return during this period. The inventiveness and commitment of the scientists, engineers, and technicians who created, constructed, and managed the spacecraft are demonstrated by the Voyager mission's endurance and success. The Voyagers have persevered in operating despite the extreme conditions and great distances they have traveled, returning data that has revolutionized our knowledge of the solar cosmos. Understanding. Gravity assist techniques proved to be a crucial component of the Voyager mission's successful implementation of multiple important concepts, making them legendary interstellar voyages. Imagine Voyagers 1 and 2 setting out on their audacious mission to investigate the furthest regions of our solar system. They required more power than their propulsion systems could give to reach these far-off locations and collect priceless data. This is when gravity helped out, kind of like a cosmic dance. These spacecraft used the powerful gravitational attraction of some of the heavyweight planets in our solar system to propel themselves forward rather than depending just on their engines. By using this cunning move, they were able to save valuable fuel and increase their speed, which helped them reach more stops on their grand tour. A gravitational slingshot, or gravity assist, is a technique where a portion of a planet's velocity is transferred to a spaceship as it passes past. Imagine Voyager 1 traveling toward Jupiter, a gigantic gas giant with a gravitational pull of its own. Voyager 1 swung by Jupiter at the proper angle and speed, thanks to meticulous work done by NASA's most intelligent minds at the Jet Propulsion Laboratory. Voyager 1 received the necessary acceleration as a result of Jupiter's gravity pulling on the spacecraft. But this move is a Voyager 1 might have experienced a cosmic disaster, of course, if it had approached Jupiter at an incorrect angle or speed. The level of precision needed is astounding, but the engineers and scientists responsible for this cosmic ballet made the right decisions on several occasions. Voyager 1 and Voyager 2 underwent an amazing solar system journey thanks to these gravity aids. For example, Voyager 2 reached Uranus and Neptune with the help of gravity from Jupiter and Saturn. These dances of the stars were essential to the Grand Tour's success. Without these slingshots, the Voyager missions would not have been the same. Thanks to the accuracy of this gravity assistance, Voyager 1 and Voyager 2 were able to reach interstellar space. Gravity assists have a very simple notion, yet they are incredibly difficult to implement. The Grand Tour of Voyager 2 demanded extreme precision. Failing to make any of these slingshots may have resulted in mission failure. However, the mission team's quest for information was unwavering and unrelenting. The Deep Space Network, DSN, played a significant role in the Voyager mission's extraordinary success in addition to their skillful utilization of gravity assistance. The DSN, which enables interplanetary spacecraft missions, is made up of sizable antennas and communication facilities spread throughout the world. The DSN's job is to keep in touch with the spacecraft during the Voyager missions, so that scientists could communicate with one another and exchange data or directives from billions of miles away. Voyager 1 and Voyager 2's communication and tracking systems became more and more important as they traveled further from Earth. The three locations of DSN, Australia, California, and Spain, ensured a constant connection that made it possible to gather crucial scientific data. The Voyager spacecraft was an incredible feat of engineering. Their sturdy platforms were engineered to reduce visual blur, while taking photographs and data as they zipped across space. They rotate at a rate more than 15 times slower than the hour hand on a clock. These spacecraft, which were outfitted with cutting-edge equipment including magnetometers, cameras, and plasma detectors, made important findings concerning the outer planets and their moons. Comparable to the interstellar phone connection that linked us to the brave Voyager probes as they ventured into the vast unknown is the Deep Space Network, DSN. But what is the DSN specifically? Its significance is equal to that of a spacecraft, despite its lack of outward appeal. Massive radio antennas positioned strategically all across the world, especially in California, Spain, and Australia, make up the DSN. With diameters spanning from 26 to an incredible 70 meters, these massive dishes serve as cosmic megaphones, allowing us to speak with spacecraft that are located far beyond our planet. The Voyager mission's success depended heavily on the DSN. Through their cameras, sensors, and other instruments, the Voyager probe served as our eyes and ears amid the expanse of space, returning invaluable data. A dependable communication system was necessary to decipher the data they communicated and deliver fresh instructions, and the DSN was crucial in this regard. Envision Voyager 1. Exploring the furthest regions of the solar system and communicating with Earth by message. This message operation, which involves it constantly searching for such far-off signals, is one of its unique features. It maintains communication with our spacecraft even when they are billions of kilometers distant, acting as an unwavering eye on the universe. This ongoing attention to detail makes sure that we stay in communication with our far-flung explorers, which enables us to collect priceless scientific data. No matter where a spacecraft is in its orbit or route, there is always a view facility to maintain contact, thanks to the DSM's global network of antennas. For deep space missions, when even a brief communication breakdown might result in the loss of vital information or the inability to send out directives on time, this redundancy is essential. This meant that the Voyager missions would always be within reach, while Voyager 1 and Voyager 2 investigated the outer planets and eventually traveled into interstellar space, transmitting amazing photos and groundbreaking scientific findings, like the active volcanoes of Io or the frozen shell of Europa, was made possible by the DSM. These discoveries might not have been made or known about in the absence of the DSM. There is more to the DSM than Voyager. It is compatible with many different types of interplanetary missions, such as those that go to Mars, the outer planets, and even beyond our solar system. Its capacity for communication across great distances is evidence of human inventiveness and the desire to explore uncharted territory. The DSN's history is likewise one of ongoing innovation. The DSN's capacity to manage greater volumes of data and sustain more accurate connections with spacecraft has grown along with technological advancements. This evolution pushes the bounds of what we can investigate and comprehend, ensuring that future missions will benefit from even more connectivity. Essentially, the Deep Space Network is our lifeline to space, not just an array of antennas. It guarantees that the narratives of the Voyager missions will be written even after the spacecraft departs from Earth and enters the unexplored region of interstellar space. We can reach farther into the wide universe thanks to the DSM, which creates a bridge between our world and the unknown. An important milestone in the Voyager probe's interstellar mission was negotiating the heliopause. This border denotes the point at which the vast interstellar space begins and the influence of the Sun begins to diminish. The precise location of the heliopause has long been unknown. First calculations suggested that it was as near as Jupiter. Nevertheless, more computations improved our comprehension. The heliopause was estimated by astronomer Bill Gurney to be somewhere between 116 and 177 astronomical units, AU, from the Sun in 1993. An AU is equivalent to approximately 93 million miles, which is the distance between Earth and the Sun. When Voyager 1 arrived at the heliopause around 20 years later,
Show de bola, né? Alfredo merece toda a nossa consideração e um grande agradecimento aí, viu, Alfredo? Mais uma vez, muito obrigado. Obrigado, meu amigo, por essa parceria, por essa ajuda, por essa força. E vamos lá, né, galera? Manda um salve para o Alfredo aí, que ele merece. E é isso aí, gente. Eu quero saber o que você achou. Quero ver o seu comentário aqui, né? Fala pra gente o que você tá achando aí, o que você achou desse vídeo aí sobre a Voyager 1. Qual a sua opinião sobre a Voyager 1? Será que a gente ainda vai captar sinal dela depois que ela sair de fato aí, que ela ultrapassar os limites finais do Sistema Solar? Fala pra gente aí. Galera, outra coisa. Vocês curtem o nosso trabalho aqui? Gostam do que a gente faz aqui? Então, aí eu vou pedir a vocês uma força aqui, que é o seguinte. Primeira coisa é isso aqui, ó. Já sentou o dedão no like? Ah, ainda não? Então vamos lá junto, ó. Isso aí. Senta o dedão no like, comenta nesse vídeo, compartilha, inscrevam-se no canal, porque quando você faz todas essas ações aí, o chamado pacotão do YouTube, né? O YouTube entende que o canal é de relevância. E sabe o que ele faz? Ele entrega o canal para mais pessoas. Lembrando aí que a gente bateu a meta aí dos 20k recentemente e a nossa nova meta é 50k. Então vamos lá, galera. Vamos dar uma força, vamos fazer esse canal chegar até mais pessoas, né? E tem outras formas também. Essa aí é crucial. Todo mundo tem que fazer para nos ajudar aqui, tá? Você curte o canal, essa aí eu vou pedir a você gentilmente que nos dê essa força. Mas tem outras coisas que é muito importante. Por exemplo, você pode comprar produtos da nossa loja, né? A nossa loja Nerd aos 50 tem camisas, tem canecas personalizadas. E a gente tem um esquema lá agora que é muito bacana. Tem uma caneca lá que você escolhe a arte. É isso aí. Você compra a caneca, né? Nós vamos receber aqui você pode mandar uma mensagem depois pro WhatsApp da loja. E aí você vai falar, né? Falar comigo não, né? Falar com a galera que cuida da loja aí. Ó, eu quero a arte tal. E aí a pessoal vai elaborar a arte, mandar para você. Na hora que você aprovar, vai imprimir a caneca e sublimar, na verdade, a caneca e te enviar. Bacana demais, né? Então, curta aí, vai lá, dá uma olhada na nossa loja Nerd aos 50. Já tá aparecendo aí para vocês o link da loja aí. E outra coisa, se você é fãzão, gosta demais do Nerd aos 50, faz igual a galera que curte muito o Nerd aos 50. Vem ser espaçonauta de carteirinha. Uai, Nerd, como é que é ser espaçonauta de carteirinha? Facinho, vou mostrar para vocês aqui, ó. Cadê? Aqui, ó, aqui embaixo, aqui, ó. Tá vendo? Tem um botão escrito Seja Membro? Pois é. Clica nesse botão, você vai ver que tem várias propostas, mas a partir, gente, de 16 centavos por dia, é muito baratinho ser membro do Nerd aos 50. A partir de 16 centavos por dia, isso dá um total de R$ 4,99 ao mês. É muito pouquinho, não é? Mas ajuda tanto, galera. Porque no montante é R$ 4,99 daqui, R$ 4,99 dali. E com isso aí a gente consegue dar uma força aí pra gente manter o canal, né? Infelizmente eu tentei ficar na parte... eu tinha 2 empregos, fiquei com um só. Tentei ficar dessa forma aí pro canal, ver se eu conseguia tocar mais o canal, mas não teve jeito, né? Ainda não tá na hora de fazer isso, eu precisei de trabalhar de novo. Então, assim, é muito suado, viu, gente? É muito suado. Então, quem puder ajudar, quem puder dar essa força e se tornar membro do canal, comprar os nossos produtos na loja Nerd aos 50, né? Tudo ajuda. Ah, outra coisa. A gente tem um curso de astronomia também, que a gente indica, está na descrição do vídeo aqui, baratinho. Para quem quer aprender um pouco mais de astronomia, quer começar na astronomia, então tá aí. O link está aqui na descrição, dá uma olhada lá também, que toda vez que você compra esse curso, a gente ganha uma pequena porcentagem. Então tudo ajuda, tá? Tudo dá uma força aqui. Então é isso aí, galera. Mais uma vez agradecer o Alfredo aí, um grande abraço para o Alfredo e um grande abraço para todos vocês aí. Lembrando que a meta agora é alta, são 50 mil inscritos, né? A gente precisa de 30 mil, quer dizer, o dobro do que a gente já tem, mais 10 mil. Então, conto com vocês nessa caminhada aí e até o nosso próximo vídeo. Grande abraço!